So I'm here at the Catania Astrophysical Observatory with Sylvain Breton, who is a Frenchman, originally from Southwest France, who is a postdoctoral researcher here, and he is also a team member of the science team for the European Space Agency PLATO mission due for launch in 2026. And unlike other members of the consortium of the team, Sylvain, your specialty is stellar physics with asteroseismology, if you could explain that, rather than planet hunting itself. But you are particularly interested in the astrophysics, the stellar physics of solar type stars that PLATO will be targeting. Tell us a bit about that.
Yeah, so maybe I can start with what is asteroseismology. So asteroseismology is the study of the oscillations of stars, because you can see the star as a ball of fluid, of plasma, so ionized gas, and this means that this ball of plasma will have resonant mode, just like if you punch the top of a drum, it will do exactly the same thing. Or if you pinch a string of a guitar, you will produce a given note. And it's exactly the same things for a star. If you pinch it correctly, it will give you a resonant mode. And by studying this resonant mode, we are able to access some of the fundamental properties of the star, such as its mass, its radius, and even using stellar evolution model, we can try to constrain its age.
And so and when you use the term oscillations, exactly what do you mean?
You have to see its waves. Just like as I'm talking right now, you have acoustic waves which are propagating in the air. You will have waves related to this oscillation that will propagate in the interior of the star. And these waves, they can be of different types. You will have just like in the air, the sound in the air, you will have acoustic wave. We call them, in asteroseismology, we call them pressure modes. But you will also have other types of oscillation. You can imagine, for example, another type of oscillation are the gravity wave. And it can look a little bit exotic, but actually it's more familiar than what we think, because if you look at the sea, the wave at the surface of the sea, they are gravity wave. So you have waves of this type that are also propagating in the inside of the star. And
so on Earth we have gravity waves propagating, not the waves that were detected by the gravitational astronomers.
No, it's not, yeah, it's very
not
important.
That, but gravity itself plays a part in the formation of waves here on Earth, in the sea, and you're saying the same forces are at work in the interior of our sun.
Yeah, it's the same that apply in the interior of our sun.
And so what are you after in observations of these 200,000 stars that PLATO is going to observe upon its launch in 2026? What do you personally hope to get out of these observations?
So what I hope to get out of this observation is a better understanding of the processes at stake in the internal region, the deepest region of this star, because they are very, very important in order to improve our understanding of stellar evolution of solar type stars. And this understanding is also at the root of our comprehension, both of our galaxy and of the exoplanets that are hosted by these stars.
And you were telling me one thing that was fascinating. You showed me a video that you had produced on your laptop of granules, individual granules in our own sun. And our sun is so massive. In comparison to Earth, how massive is our sun? It's like what?
So our sun would be, so I can give you in comparison with Jupiter. So if I'm correct, the sun will be 99.7% of the total mass of the solar system. So this is to be checked, but I guess this is
So it's almost the sun makes up most of the mass
exactly,
of the solar system.
The vast majority, and Jupiter is 0.2, and what remains, the final 0.1, is all remains, among which the Earth.
And what you're also trying to do is understand the granular effects that occur in the photosphere, the surface of our own sun. And you were showing me a video where you have these granules. It looks kind of like kernels of corn before it's popped, and that's that's what it reminded me of. And anyway, so you look at these granules, and you said one individual granule is the size of France, the country of France. I mean, that's amazing, because France, you know, it's a large European country. So I mean, we're talking, you know, these things are on massive scales. So,
yes.
So finally, at the end of the day, what do you hope to be able to get from the PLATO observations? I mean, how much will our understanding of the ages of solar type stars, how that relates to the ages of the planetary systems that surround them, how will this all correlate to give us a better understanding of the star-planet interactions?
Yes. So what we hope to get is then, first we'll get an order of magnitude at least more of main sequence solar type stars, so stars that are about the same age as the Sun, than we got with previous mission. Because when you consider these stars, with the Kepler mission, we only got a few more than 600 stars of this type. Now, after that, there was the K2 mission and the TESS mission, which provided a few more, but we hope with PLATO to get at least thousands of them. And so with this star, we hope to be able to get very good constraint on the mass, the radius, the age of the star. And this, we are going to compare it with our current stellar evolution model. And we will use this observation to improve our stellar evolution model. And when we are able to improve our stellar evolution model, it will be the first step to also, at the same time, refine all the planetary formation scenarios to get a better understanding of how planet appears, how they evolve, how the evolution will be driven, among other things, by the tidal interaction between the planet and the star, by magnetic interaction between the planet and the star. So there are a lot of fascinating interrogation for which we hope to be able to provide more insights with PLATO.
So thank you very much, Sylvain, for taking the time to explain some of this. And we're living in exciting times. In 2026, we're going to begin a new journey of understanding solar type stars within the galaxy, and we'll be looking for your work when the first results are released. Thank you so much again.
Thanks a lot.